question. Anything you'd like to ask. We normally have something called, so today is the 31st. So I normally create for you at the beginning of the class something called a daily concept puzzle. I did not create one today because we really didn't have anything else, anything to discuss, just X and Y intercepts and how to plug in numbers in a formula. But normally we have that daily concept puzzle before we start new material or your questions, but not today. Good, I'm ready. Yes, Rakita, go ahead, please. Any question, anything you would like to start with? You are muted. Rakita, can you hear me?
Say it again, I'm sorry.
Yeah, we are ready for your question. We start with your question. Anything you want.
I probably should wait because it's R.2, but I can still give it to you.
Yes, so if it's in R.2, allow me to finish R.1, and when we start R.2 and we get to that topic, then you say, I have a question, and we'll do that.
Yeah.
Is that okay?
Yeah.
Perfect.
That's fine, yeah.
Okay, so we are going back to R.1. I have the book up here. Let me share my screen. Where are you guys? I have so many different things open here. Okay, got it. So we're going to go directly to page 23. Okay. Actually, I meant page 10, problem 23. That's, sorry about that. Because we haven't finished R.1. I still have to show you a few examples. So 23 on page 10. Okay. So we have here a question on ibuprofen. It's a medication used to relieve pain. We have a formula, as you see it here. And we do have the information that T is number of hours. So T is in hours, and it's somewhere between 0 and 6. So I'm going to take my notes, T in the interval 0 to 6. I'm going to copy the formula, which should be A of T, not just A. It's a function of T. So we have 0.5 T to the 4th plus 3.45 T to the 3rd minus 96.65 T squared plus 347.7 T. And this is, A is in milligrams, so I will always take notes. The measurement unit is very important. Of ibuprofen in the bloodstream T hours after 400 milligrams of the medication has been swallowed. So if I take now a tablet of 400 milligrams of ibuprofen, we suddenly expect that during the next, at least, I don't know, 6 years, but 6 hours, because that's what we have here. So time is T is in hours, the concentration to go down, right? I'm getting 400 milligrams now. In an hour or 2 or 3 or 4 or 5, it should be lower and lower and lower. How many milligrams of ibuprofen are in the bloodstream 2 hours after 400 milligrams has been swallowed? So can anyone tell us, what are we asked to do? What do you think we're asked to do? Anyone, please.
Would T be replaced with 2?
Exactly, A of 2. So now let's take a look at how to enter this in the graphing calculator. You can say, I don't want to enter this in the graphing calculator for only one value. However, what if the problem, like the previous one, when we talked about the compound interest formula, what if I had 5 different values to enter, right? So it's always safer and better to enter the function first and then plug in the values that you need instead of plugging in it directly, because it will take you longer. And not just that, but also you may have errors. You may get errors in the final answer. Okay, it's always safer to put the function in, as long as we put the function in correctly. So now I'm going to share my screen and go to the graphing calculator, and I'm going to record this. So Rakita, if you want to turn off your camera, if you like, I'm going to record the screen now. Whenever I record the screen, I'll let you know. So Rakita, can you hear me? Rakita, can you hear me? So if you want to turn off your camera, just for a minute, because I'm going to record the screen. If you want, you don't have to. I just wanted to give you the warning.
I just have one question.
Sure.
What did you press on the calculator to get there again?
So I'm gonna show everything from the beginning, and I'm going to record it.
Okay, gotcha. Thank you.
Okay, so we go to y equal. First of all, I would like us to go to second and table set first. So it doesn't matter where you start. This is arbitrary. It doesn't matter. You don't have to put anything in here. Whatever it is, it's fine. Whatever you have, don't change it. But the independent variable has to be in ask mode, not the dependent. But the independent variable has to be in ask mode. If you don't have it in ask mode, scroll down, go to the right, highlight ask, and press enter. So this is the first thing we need to do.
I'm sorry, what did you press again to get to that screen?
You mean from the beginning?
Yeah.
So, second and table set. Right here in blue, it says table set.
Right.
And everything that is in blue has to be activated with a so-called second key.
Right.
So, second and table set, and make sure that the independent variable is in the ask mode. Then you can second and quit, get out of there. Now we go to y equals, and I will clear whatever I had before, and I will enter the new function. T is not in the calculator, but x is in. It doesn't matter. If it's t or x or b or c, it doesn't matter, right? So we have 0.5, t to the 4th power, put the caret and 4, come back down, plus 3.45, and x to the 3rd power, and then minus 96.65, and this is t squared. The squared power is here. You don't need the caret. Just for the squared, it's up here. And then plus 347.7 x. That's not what I meant. Don't copy that. Plus 347.7 t, which is x. If you made the same error, clear the second one. So this is the function. I entered it. All I need to do now is just second and table and plug in 2. And here it is. It happened that it was already there because we worked on it on Tuesday night. And we had 2 in there. That's why it's there. Always go to the right and highlight to make sure that you see all the decimal digits that you need to. So A of t is 344.40. Now, what is the measurement unit? Without the measurement unit, we can't move on. What is the measurement unit here? And I can stop sharing. I meant stop recording.
Milligram?
Milligrams indeed. Awesome. That's what we said. So this is it. That's all we needed to do for A of 2. Now back to sharing my screen, and let's go back to the next problem. I wanted to move on to problem 41 on 12. I always ask you to choose problems. If you want to, feel free to choose. So on problem on page 12, I wanted to look at this 41. This is also good for financing. Okay. So it's a retirement account, but it can be any account. Sally makes deposits into a retirement account. So one more time. As you know, ask any questions. This is not a monologue. Please unmute yourselves and ask any question anytime. Clear? Okay. Give me a something. Yes? Okay.
Yeah.
Awesome. Thank you. That's not what I meant. I meant this. Yes. So back to the problem. So Sally makes deposits into a retirement account every year from age 30 until she retires at age 65. If Sally deposits 1,200, so this is 41 on page 12. So 1,200, interest rate 4% per year, compounded annually. Okay. I'm taking all these notes. How much will she have in the account when she retires? Okay, so at the age of 65, right? So she started at the age of 30, so between 30 and 65. So how much will she have when she retires? Can anyone refresh our memory on the formula we need to use here? Any formula that you can come up with? Anyone?
It's T
Yes?
A equals G 1 plus R over N raised to N times T.
Very good. Awesome. That's perfect. So what is the information given to us? In other words, what is the principle?
1,200.
1,200. Awesome. So when we talk about annually, compounded annually, how much is N?
12.
Annually.
Oh, 1.
Exactly. Awesome. So N is 1. How much is the interest rate? And how do I enter it?
It's 4%. It's going to be 0.04.
Brilliant. Awesome. And now, how many years?
One.
Careful. How many years?
35.
35. Awesome. So A equals 1,200, 1 plus 0.04 raised to 35. Please do not perform the calculation step by step. You're going to introduce a lot of error. So all we have to do, yes, it's just one calculation, fine. So left parenthesis, 1.04, because I can add 1 to 0.04. And don't forget the caret. You know me, I like parentheses unless you don't want to. In this case, it will work. So I will click on enter. And this is what she will have in her retirement account 35 years later when she's supposed to retire.
I have a question.
Yes.
How do you put the power after
Caret, right here, caret.
Okay, I press that and then I just put in any number, right?
So, yes. How much of the total amount is from Sally's deposits? How much is interest? Every year from age 30 until she retires. If Sally deposits $1,200 per year and the account earns an interest rate of 4% per year, compounded annually, how much will she have in the account when she retires? Use the they are asking us to use the annuity formula. So in this particular case, we are not using the accumulated interest formula, because when I looked at the amount that we got, I said, no, this cannot be. So it says here, we do have to use the annuity formula given in 37. Okay, so the investment fund is not using the accumulated of the compounded interest formula. The investment fund is using this formula instead of the accumulated interest formula, the accumulated with the n times per year. Okay, so I should have finished reading. So that's a okay calculation, but it's not for the retirement fund. So if P dollars are invested annually at an annuity, because it was an annuity, that was the thing. Okay, it's a retirement account. So that's why they're giving us the hint. Use the formula from exercises 37 and 38. So I have to copy it again. We have all the information. So we have 1,200 and we have 1 plus 0.04. Everything goes in the same way. -1 divided by 0.04. It's just that we have to be careful. Let me show you. So everything is the same. 0.04 is the same. 35 is the same. 0.04 is the same. But we have to be careful how we enter this in the graphing calculator. So here it is. So 1,200 stays outside. No problem there. We have to put parentheses around the numerator. And then parentheses again for, although since the calculation is just 1 plus 0.04, I can write it without parentheses. Caret, power 35. Don't forget to come down from that power. -1, close, and then divide by 0.04. It better be substantial over 35 years. Okay, so it's 88,382.67. Back to the formula one more time. That's not here, that's here. So the principal, 1.04, power 35, -1 divided by 0.04. So this is what we got. Now the second part. How much of that total amount is from Sally's deposits? So we know that she deposits 1,200 multiplied by 35 years. That is what she deposited. So when we multiply 1,200 multiplied by 35 years, she deposited 42,000. So from 88,382.67, this is coming from her money. The rest is the interest. So I'm going to write it like this: 42,000, and the rest is interest. What is the interest? 88,000. Let me stop sharing. 88,382.67 minus 42,000. So you will see me write minus here and minus here. Are these two minuses? No. All it means is that this is not the end. follow the minus and continue. It doesn't mean that we have two minuses. So we subtract and we get in interest, that's my page 2. In interest, what does she get? So it gets 46,382.67. So she deposited 42,000 and she got, in addition to that, 35 years later, she got this extra, which is the interest. So this is her entire amount, but she deposited 42,000 over 35 years. So this is the interest that she obtained over 35 years. When she retires, she gets this in her retirement account. Any questions on this? Is everyone okay with this calculation?
Yes.
Perfect. Any questions?
The only question I have is when you're
Yes.
saying interest, is she paying interest on the money she's putting into that
No,
account?
no. So she deposits this amount over 35 years, and the
Right.
retirement account is giving her this amount.
Okay, gotcha.
So at the end, when she retires, she gets this into her bank account. She can transfer it from the investment account into her bank account.